Okay, I think this is up to part 5 of your exam review, exponential and logarithms. So it just tells you to plug it in the calculator, so we will. Second e to the 4.3, and our answer is 73.7 or 73.69. The e is right here above natural logs, just hit second to get to that e to the x. Okay, next is number 2. Number 2 asks us to use the interest equations to evaluate an investment of $20,000. Sorry, technical difficulties. $20,000 at 6% interest compounded semi-annually for 13 years. Since it's compounded semi-annually, you have to use this equation. The PERT equation is only for compounded continuously. So I put 20,000 in for P. My interest rate is 0.06. Semi-annually means twice a year. So 2 goes in for both ends. And T is time, that's 13 years. If you plug all that in your calculator, you should get $43,131.83. Now in number 3 it says that someone is deciding between two investments. Account A offers a rate of 5% compounded daily. So we have $300 we're investing at 5% compounded daily. That's 365 times per year. And the time is 10 years. Okay, that's the first option. And then account B offers 4.9% compounded continuously. So that's where the PERT equation comes in, when you're compounding continuously. So I do 300 e to the 0.049, that's 4.9%, times the 10 years needed. So let's compare both of these. We'll do 300 times parentheses 1 plus point. Sorry, that should be 0.05. Very sorry. That would give us a very wrong answer. I gave us 50% instead of 5. Wishful thinking. So 0.05 for the percent over 365 raised to the 365 times 10 years. So that account will earn her, seems high, 1 second. I see my mistake now. I forgot my raised to the. So let's go back and fix that. I need a exponent right there. There we go. Much better. That makes a lot more sense. Okay, so $494.60 is what account A will get her. So let's compare that with account B, where she's compounding continuously with a slightly smaller interest rate. Sorry, I went too many zeros. Second e to the 0.049 times 10. And we get $489. So that lower interest rate makes the difference, even though it's compounded continuously. 489.69. So that is lower. So account A is the better choice. Account B, you can do this in your calculator. Now mine doesn't have this, but if you go to math on your calculator, you go all the way down, there's actually, on yours there's things below 0, and one of them just to say log base, and that'll let you plug this in real easily. Now if you don't have that, then you can also do it this way. You can do log of 16 divided by log of 2, and you get 4. Same thing. So let's go to number 5. If we add 1 to both sides, we've got to find a way to get that x out of the exponent. And the way we do that is we take the natural log of both sides. Because then, what natural logs allow you to do is move the exponents down front. So you get 0.3x natural log of 7 equals the natural log of 813. So divide both sides by the natural log of 7 and by 0.3. So natural log of 813 divided by natural log of 7 divided by 0.3 to get our answer of 11.478 or 11.48. Now, number 6, we cannot do this. We can't do 2 logs very easily when we're solving. So what we do is we use the properties of logs, which allow us to take these 2 logs that are being added together and combine them into a single logarithm where their insides are being multiplied. So remember, addition changes to multiplication and subtraction changes to division. So now that it's just 1 log, I can get rid of the log. And the way I do that is by raising it as a power of 5. So that cancels this out. Here I'm going to go ahead and FOIL that, get x squared minus 4 equals 25, because 5 squared is 25. I'm going to add 4 to both sides, take the square root of both sides, and get x is equal to plus or minus the square root of 29. Now actually, you can't use the negative one, because you can't use negatives in the square root, so we're just going to have the positive version here. Alright, several of you had questions about 7 and 8 with a pH. The formula is right here. This may not look like a formula, but it is. pH is equal to negative log of x. So find the pH in number 7. So we're looking for this. That has a hydrogen ion concentration of 7.9 times 10 to the negative 4th. So all you do is plug in 7.9 times 10 to the negative 4th in there, and let's see what we get. So negative log of 7.9 times 10 to the negative 4th. And we get 3.1 as the pH. Okay, now 8's a little tougher because it says what would be the hydrogen ion concentration, that's x we're looking for, if the pH is 9.3. So that means we have to solve for x. Well, I want to move the negative over, get rid of it, so I get this. Now this is called the common log, the one we don't write a base for. The understood base, though, is 10. Now to get rid of that, we'll raise both sides as powers of 10. So we get x equals 10 raised to the negative 9.3 as our answer. So common logs have a base of 10, natural logs have a base of e. Number 9. In 2000, the average sales price of a car was $22,000. So that is the beginning price. You put that in for A0. By 2009, that's 9 years later, so I'll go ahead and tell you that's probably going to be our time. It had increased to $28,000. So that's our new amount, and we put that out here. Use the exponential growth model, in which t is the number of years after 2000, to find the exponential growth function that models the data. Okay, so we're looking for the equation, which means we need to solve for k, because a and t are our variables. We want those there, but a and k are constants we need to solve for. So we already have our a. Now we're going to use this information to solve for k. So divide both sides by 22,000, and you get 28 over 22. I'm not going to reduce that for right now. To get rid of the e, you take the natural log of both sides. See, I know that reduces to 14 over 11. The natural log and e cancel out. Now I divide both sides by 9. So, time for my calculator. Natural log of 14 over 11. Close the parentheses. And then divide that by 9. We get 0.0267. So k equals 0.0267. Make sure I wrote that right. Yeah, we'll round it up to 0.268. So that's our k. So our equation is going to be a equals 22,000 e to the 0.0268 t. I think on the answer she actually just rounded that to 0.027. Number 10, the population of China can be modeled by this equation, and t is the number of years after 1984. So what is the population of China in 1984? Well, that would be year 0. If you plug 0 in for the time, all you're going to be left with is 987. Now that's generally true with exponential equations. Your coefficient is what you started with. It's how much you had at time 0. So for part A, it's 987 million. Okay, B, at what rate is it growing? Okay, that's right here. Your rate is the K, or the R. So that's a 3.4% growth rate. C, what was the population of China in 2004 to the nearest person? Well, 2004 is 20 years after 1984, so just plug that in, times e to the 0.034 times 20 years. Sorry, I hit a wrong key somewhere. Let's start over. 987, second e. Raised to the 0.034 times 20 years. There we go. So it's going to be approximately 1,948.21 million. So that's 1.9 billion. D, in what year will the population be 1738 million? So we plug 1738 in for A and solve. Okay, divide both sides by 987. And then to get rid of the e, we take the natural log. That cancels out the e. So let's go ahead and do that part. Natural log of 1738 over 987. We get that number. That number, 0.565, is equal to 0.034t. So then we divide this number by 0.034 to find the time of 16.64 years. So that's 16 years after 1984, which would be the year 2000. Number 11, we're rewriting this. Remember, log BAP. Okay? So log base answer equals power. Normally you have base raised to a power equals the answer. So you're trying to get it back to that format. So our base is 3. Our power is x. Our answer is 9. Base, answer, power. Oops, sorry, I said that wrong. Base, answer, power. There we go, log BAP. So again, this is our base, this is our answer, this is our power. So we do log BAP when we're converting to the other way. 13, you can just plug these in your calculator. Again, I have to do it using division, so I have to do log of 1 over log of 5. You should be able to use the log base in your calculator. So I get 0 for that one, and then log 9 over log 3, and I get 2 for that one. Point here is to make sure you see that things can cancel out. Anytime these two numbers match, everything cancels out, leaving just the exponent, 5x minus 1. Also, e and natural log cancel each other out, so it just leaves the answer of 45. Okay, we're getting close, ish. 17, I have this plugged in already for us in the stat plot. So it says plug these values and run an exponential regression. So I will go to stat, calc. I believe exponential is the 0. Let's see if that's right. It is. Let's plug that in y equals just in case we need it. Okay, so we get that. So the equation would be 3.66 times 1 to the x, basically. Now what the r squared is what tells us how good of a fit that would be. So our r squared for this one is 0.708. Okay, not a great looking r squared. So it's not looking promising that this is exponential. Remember, exponential has this shape. Log has this shape. So actually, before we go any farther, let's look at the scatter plot for this. Let's go to our stat plot, turn on our scatter plot here. And remember, when you use the stat stuff, use zoom 9. Okay, so hopefully you can see why that's not exponential. Exponential, again, starts slow and then moves fast. Log starts fast and moves slow. So it looks like log is going to be a better match for us anyway. So now let's do part C and calculate the log. There it is, natural log, vars, y1. And our equation is 2.73 plus 0.35 natural log of x. And that r squared is so much better. It's 0.99. That's a really, really good r squared. You want to be as close to 1 as you can. Now E says graph the two equations from part A and C. Based on that, which equation seems to be the better choice? Clearly the natural log equation is the better choice. Higher r squared and fits the shape better. Okay, number 8, we're looking at domain. So here's what you got to remember. The domain of logarithms has to be greater than 0. This inside part has to be greater than 0. So if I subtract 1 from both sides, I'm told that x has to be greater than or equal to 1, just greater than -1, which means you can go from -1 all the way up to infinity. Now 19, this is still true that x minus 6 squared has to be greater than 0, but a squared is always going to be greater than 0 except in one situation. And that situation is when you actually equal 0. So the only thing you're going to get if you have a squared here is that x cannot equal 6, because that would make it 0, and 0 is not greater than itself. Okay, this is actually the last one. 21 on, the printer didn't do it right, so this will be the last one for this section. Okay, so we're expanding this. According to the properties of log, if you are dividing, you can split that up as subtracting. Okay, and 2 is being multiplied by x to the 5th, and multiplying can be split up as addition. And finally, exponents can come down as coefficients. So square root of x, I just rewrote it as x to the 1/2. So I can bring a 5 out front here and a 1/2 out front here, giving us our final answer. Just remember, division to subtraction, multiplication to addition, exponents to coefficients.